Awesome. Tena koutou katoa, ko Shofe toku inoa. Tena koutou, tena koutou, tena koutou katoa. Good afternoon, everyone. Thank you for coming. It's such a big room, and it's almost filled up. Props for that. Before we get started, I just wanted to ask you a question. How many of you here have actually dealt with mobile application before, be that testing, writing, or even security testing? That's quite a lot of hands. Great. Before we get started today, I would like to introduce myself first, some self-promotion. My name is Shofe. As our host already said before, I've been in the security industry for some time, almost 4 years now. Been working with CyberCX, mostly doing security consultancy, and also I like doing web application testing, source code reviews, and mobile stuff in general. I am also a human, so I do go outside time to time, play cricket, some badminton, and presenting when there is something new coming up. Some of you might also recognize me from Hack and Learn. This is a monthly meetup that we used to run. We're not so active after COVID, but trying to get back to pace again, pick up the pace again. When I present something, I usually try to come up with a why, right? Why are we presenting about something breaking mobile apps? This is something we do day to day. And we test new features. We test what they are trying to do, what they're trying to achieve, and see how the security side of things looks like. Sometimes we stumble upon stuff that we just cannot get around. Annoying pop-up that just keeps popping up, or just another side window that wouldn't let you access the main app until you do some specific action. So today we are going to talk about some restrictions that we have seen over the past years of testing. We'll talk about how we got around it, and probably some takeaways, especially for the devs and testers, things that we can do to further secure our applications. Let's start with the agenda. I probably already went through most of it. However, there is one thing in particular that we want to focus is the apps that are cross-platform. We'll look into these anti-tampering libraries that detects if you're trying to make any change. We'll talk about challenges and overall bypassing them. And finally, there are some takeaways for if you're a developer, what can you do? Let's start with this one first. How many of you recognize these two logos, Flutter or Xamarin? That's quite a show of hands. They are called cross-platform frameworks that you can use to deploy application for different infrastructure, I would say, or different operating system, iOS and Android being the two major ones. You write one piece of code and get distributed to two different app stores, and you get the job done much faster. What it helps with is it makes deployment stuff easier. You only have to write things once. But what makes it difficult for us as a tester is anything that we come up with get patched really fast, and it's across two different environments all at the same time. So you're playing that constant cat and mouse chase game where you come up with a bypass, get patched, and now you have to work on a different one. Before we get into the nitty-gritty details, I just wanted to get some buzzwords or keywords out of the way. I hope a lot of us here knows what jailbreaking is or rooting is. If you don't, the simplest way to explain it is it's a process where you can remove the restrictions imposed by the operating system. Apple will hate you for doing that, however, you can do it. It offers privileged access to the phone. One thing that it will allow you to have is install a modified application, the ones that are not certified from App Store. You can install tweaks to get things done the way you want. And Android equivalent to it is called rooting, which is probably more well-known. Now, why do we need jailbreak, and what is anti-tampering libraries? Here, I tried to go into some details about what anti-tampering libraries is, but why do we need jailbreak, right? When we are testing an app as a security researcher, we want to have more access to the system rather than just what the app can do. We want to see where else in the system the app can make an impact. Also, we want to run our tools against the app to see how the app behaves, putting into a constraint situation. That's our justification of why we need jailbreak. But as a developer, you will look into it as something like, for example, a gaming app or a financial app where you're storing sensitive customer information. Or in a gaming app where you hate to lose, but this modder coming in and just stealing all the scores. Or they are making you lose every time, but they're utilizing a complex algorithm or whatever they're doing. As a developer, you would want to prevent that to maintain stability in your system. So what this anti-tampering libraries does is that it detects all those malicious actions. It will try to prevent you from accessing the app functionality. Sometimes it just limits it. For example, you can browse to the app. As soon as you're trying to do anything sensitive, it will trigger, and you no longer have access to the app's functionality. Let's talk about some challenges dealing with these anti-tampering libraries. Yeah, it's nice from a development perspective, but when we are testing and we are trying to just get access to app features, this can be annoying. It does an extensive list of checks, and there are third-party libraries now that are open source and actively maintained. The problem it creates is it creates barrier for us to now go and test. Also, when you deploy mobile application, the source code are not that beautiful to look at when it gets compiled back to low level or assembly language. So here we come, and here we stand. We have something that we cannot test. Now we need to reverse engineer, figure out how to get around this. I guess that's enough with theories. Let's talk about different side of challenges, right? What are the resources do we have? If you go to something called Frida CodeShare, I'll get more into Frida later on. You will find script that other people have written in the past that let them bypass this protection. The only issue is the libraries are constantly being updated. So our old script will no longer work based on the pattern that it was developed for. And then you can see Frida jailbreak bypass. All of these focuses on specific things. So to better understand how this process works and to come up with a bypass, and a bypass that actually works relatively more frequently or it's harder to patch, we built our own application using Flutter. This is how the source code looks like. Really simple app. Where I highlighted is where it's calling the IOSSecuritySuite. It's an open source anti-jailbreak detection or anti-tampering detection library that you can use to build your app. And then it will run a list of checks, which we'll go on about. And finally, in line 16, just below that, it will produce a result. And based on the result, on the left-hand side, probably, you see the app is stating the system you're running it on is jailbroken, or the mobile is jailbroken. So that's such a simple concept for us to verify if it works or not, how it works. So let's focus on how it does these checks. If you look at the first screenshot, I'll try to bring only the first one first. What it's doing is it's creating another function called making use of the function perform checks, which is probably doing some sort of checks. And if we go on the next screenshot, we will see it's checking for a whole bunch of stuff, URL schemes, looking for suspicious files, things that you can look for, directories that you can write in. So you might be wondering, why is it checking for this, right? In a vanilla installation of iOS, you wouldn't find files like this. You wouldn't find some of these directories existing, and you wouldn't find some of this file existing because it's non-Apple, and someone probably went ahead, jailbroken it, and added a file over there to serve their purpose. Now, to be able to bypass this, if we take a look at the function again, the app that we built, we looked at it's checking for some stuff, and then it's giving us a result. One way to do it is, if we go back, is to go into all of these checks. For example, in here, check existence of suspicious files, and set the return value of all these checks to false. So the app will think your device is not jailbroken, assuming that you can control, while the app runs, that you can control the outcome. Or what if, instead of doing all that, we can just go back to the parent function and influence the result that's coming out of it. So at first I was thinking, this could be fun, right? All I have to do is to go and change this. Entering assembly. The reason for this big sigh is apps get compiled into low-level language that are no longer that easily readable anymore. You have these sets of instructions, some of them harder to read, takes some time getting used to. However, I tried to boil it down or dumb it down here just to show the core function. Here we can see what used to look like a readable code, now not so much. If you look at number 1, we can see the function name is somewhat obfuscated. We can see the parent name and the function that's actually doing the checks. And on number 4, we are seeing an outcome. So in theory, if we can influence that outcome, something good might come out of it. I tried to be lazy here. Instead of controlling the outcome, just set it to do nothing. This is an op instruction, which does basically nothing at all. No. What it will do, the jailbreak check will happen. However, there will be no result. And based on the condition, if there is no result, we shouldn't get a trigger from the library, tampering library. And here we go. What we do is we then repackage that library file, package it with the application, install, and boom. We no longer have the tampering library coming in and preventing us from accessing some functions. But this was quite exhausting, isn't it? You look at this file, you go into assembly, and now you have to do for all the apps that are coming along the way. What if there is a more reliable way to do this? Here we go into the arena of dynamic instrumentation. Is any of you familiar with Frida, objection? Oh, there's quite a few show of hands. Just a quick intro. What Frida does is when you run the app, it lets you access the runtime of the application. Think of it as you can control any outcome of any function inside the application while you're running it. In the past, we have made use of this Frida to do all sorts of destructive stuff. For example, you have Candy Crush and suddenly you have 99,000 coins. All these cool things that you can do, hack you can do, unlock the stuff that weren't unlocked before. What Frida and objection is built on top of Frida to just make things easier. With the power of Frida, you can write your own script. You can write your own code that will affect some specific part of the application. It is quite important, and I'll tell you why. There's another tool. Sorry for dropping all the tool on your face, but I promise that's the last tool I'm going to talk about. This is called Grapefruit. We all love GUI. I'm no exception. All it does is lets you access Frida from a web GUI, and it will let you access all these functions, tell you where they are in memory, and will give you a nice script that you can use as a baseline to hook into those functions. Now, if it was a game, I would give myself unlimited coins. Because this is an application that I want to get around their jailbreak detection checks, I would want to focus on their jailbreak detection library. And here you go. It probably won't tell you much. That's why we have a demo. However, you can see the terminal output showing you that this specific function that's used by the tampering library is getting called. It will show you all the stack traces, also memory address spaces, how it's running, how it's originating from. And at the end, okay, the cursor not coming up, you can see 0x1 means the jailbreak detection saying your device is jailbroken. However, our script went ahead and modified that to set it to false. And on the right-hand side, we can see now it's showing as no. So the app is now thinking the device is not jailbroken. That's a lot of theory, right? Let's try to do a demo to see things in action, and hopefully it makes sense. coming here. Okay, cool. So here we have a test bench. On your left-hand side, you'll see my screen, my virtual machine, and on the right-hand side, I managed to capture the screen of the phone so we can see things happening live. What we do first is, we talked about grapefruit before. We go to the web interface, and we browse to the application. What it will do, it will let us know the basic information of the app. So we have built two applications. One is more glamorous than others, because just saying yes and no probably doesn't look so good for a demo. So we get into our first application, and as soon as we click, you'll see on the right-hand side the app is opening up, means we are into action now. And once that happens, we can utilize Grapefruit to list all the libraries that are running in the background. In our case, it's really simple. IOSSecuritySuite is the only one that we are using. And once we get inside that, we can now list all the functions. Now it's starting to make sense. The jailbreak checker is coming into place. Some other stuff that we have seen in the source before. What it also lets us do is it lets us jump into the low-level language straight away. So we can go and search here, focus on the specific function that we were looking for before. And once we click on this, it will jump straight into the assembly language. So in this case, you don't need to utilize a disassembler or another tool to just read the source code or the low-level code. All it does in one place. I've also talked about a template script, right? It gives you a template script that we can take and then start debugging and see how the function operates. Let's take that. Here in our terminal, we open a JavaScript file. Frida accepts JavaScript code that you can give it. It will basically list all the things. First thing we could do is run a command to see what apps are installed. Here we can see 2 of our apps are installed. Take the name. Hurry up, demo. So here we can see the app launched again, and our script letting us know, yes, that function has been called. Okay, that's cool and all, right? But we want to make some impact, do some changes in the runtime. So here is the second script that comes in. What it will do, it will let us know more details about the app, the call stack it's doing, what it's seeing, memory address it is utilizing. So we do that, and now we see a bunch more information. Even here it's useless to us. We want a result. So here is where the third bypass script comes in. And once we run this, it's so fast, it's really hard to track. And we can see on the right-hand side, the device is not jailbroken, even though it is. At this point, I was like, okay, that's cool, right? But how do we show it as a cool project? When you're testing apps, you can limit the user's functionality. You can completely ignore if the device is jailbroken or not. Or you can implement something like a persistent overlay over there on the right-hand side. And I'll show you that it's persistent, that when you go back home and come back, try to avoid this. It wouldn't let you access the app until you can prove that you're not jailbroken. So I go back into my home, come back, and try to run the script now to see what happens. So we exit out, run our script, and here you go. It happens so fast that you wouldn't even see it. But to prove that it worked and that the script is a one-time thing, we can run that thing again, but without the bypass script now. Here we go. Here we can see the error message coming up again. And these scripts, what it allows us to do is to reuse it against different applications. Previously, our issue was we modified once, and that's one-time use. In this case, we can reuse it every time the iOS security library is in use. So that's all for the demo. Now, let's get back to presentation. It's all cool and all, right? As a security researcher, it's really cool. We can bypass stuff. But what it doesn't send a good message to the developer. How can you be confident now that you can bypass these anti-tampering libraries? And even after its invention, it has gone through multiple stages. However, we can still bypass it. So there are some things that we can do as a developer or help as a developer to implement in our application, introduce new stuff that makes it harder to reverse engineer, to understand the flow of the code. For example, the first thing is code obfuscation. Anyone familiar with this? What it does? We'll do a quick demo after that, just a picture. Runtime detection, for example, when we made changes into the memory, there will be stuff that you can implement that will detect it and will prevent it from happening. There are other stuff we can do. For example, restricting app functions. You can probably let the user use the app as usual. However, if you detect that the app is running in a dangerous environment, you can restrict some of the features. Or, just for future reference, or to know where these dangers are coming from, log it to somewhere remote. As soon as you log into the application will let the server know something's going on. We talked about code obfuscation. We talked about multiple ways to skin a cat, right? You can do things differently. These are the two common ways of doing it. First, you remove the predictability from the code by changing the names or making it really short. On the right-hand side, you just mess up the pattern. In our case, we went from the source code into the assembly code, but because there was a pattern we could follow, and because the library was open source, we could follow where the code was going. We just had to intercept at the middle point where it was necessary. In this case, if you break it, someone coming to reverse engineer and develop a bypass will have a really hard time figuring out. All it does is basically increases the effort that you will need to get into an application. Now, if you're a developer, you would want as many barriers as possible for people to try and do cheeky stuff with your application. The effort you put in results in someone giving up early on rather than persisting and coming up, destroying whatever protection mechanism you had in place. So that's the first point that I wanted to bring about is detection libraries are good. However, they have caveats, and given enough time, whatever protection mechanism you have in place, if someone is motivated enough, they will probably get around it. Building all of these protection one after another, following a layering approach, will give you a better security posture, I would say. Just make it harder for us to do. I know it's counterintuitive as a security researcher coming and saying to the developers, make it harder for us. However, once enough friction is there, we'll probably give up early on as a threat. That's pretty much the entire message of this is if there's something to take away from this is consider taking multiple approaches rather than just relying on one library to do all the job for you. Yes, IOSSecuritySuite does runtime detection, does jailbreak checking, does check if you're running as developer mode. However, as we have proved, given enough time, it's possible to get around them. Now, before finishing this off, I tried to push another slide into this. However, looks like I need to just present it as it is. With this talk, there is a blog post coming on from CyberCX. I will link that into the OWASP talk if I can later on. However, just keep an eye on CCX blog. Just Google that, and the first post you will see should be for technical details for this talk. And finally, the tool that we used, the Frida script that we used, and the binary that we modified are still there in our CyberCX GitHub. It's published for people to have a look at what we have done, how we bypassed it, if you wish to use it. And finally, we are out. We have a booth over here, CyberCX. We are cool people doing some cool research, working on some cool stuff. If you want to reach out to us, feel free to grab one of us from the booth. Would like to have a chat. And if you have any questions, I'll be around, so just grab me. Thank you for listening.